My name is Katherine, and I'm a Grateful Arc Scholar. I'm a fifth-year PhD candidate at UC Davis, and this is my second year being supported by ARCS. My research focuses on the patterns and processes underlying the diversity of life on Earth. So I'm interested in how evolution over millions of years can produce the incredible array of animals that we have today. Specifically, I study evolutionary biomechanics, or how the physical properties of interaction with the environment around organisms affects their evolution. And so feeding is a particularly crucial aspect of an animal's life. And I study how the different ways that fishes can capture their prey on coral reefs affects their diversification. Almost every fish alive captures its prey using suction feeding. So suction feeding is a really dynamic physical process that relies on rapid expansion of the head and jaws to suck in both water and a prey item. So if you think about a suction strike, on the left is the start of a suction strike where the fish's jaws are closed, and the fish will swim forward and expand its jaws to capture the zebrafish. So here on the right is the fish at its maximum gape, and you can see the incredible amount of shape change caused by expansion of the head and jaws. And so overall, there are so many different aspects of the fish's head and body, bones, muscles, ligaments that have moved in order to create a low pressure region inside the mouth to pull in the prey. And this process is really dynamic and involves the mechanics of the entire body. But although every fish can use suction, not all prey lends itself easily to being sucked in by a hungry fish, and especially not a lot of the prey that are really common on coral reefs, like algae, corals, and sponges. And so those prey require direct contact with the jaws in order to scrape or grasp the prey item and pull it off the substrate. So we call this biting, which is a feeding mechanism much more analogous to the way that terrestrial vertebrates and humans eat. What you see here is the motion of a biting strike by a parrotfish who scrapes algae off of the surface at the bottom of the strike. And so biting is a really different process than suction because it requires the force to be passed directly through the jaws to the prey item. But remember, in fishes, everything that uses biting still also uses suction because they have to be able to move the prey inside their mouth after they've picked it off the substrate, and they don't have a mobile tongue like we do. And so one thing I want you to take home here is that feeding really is a full body mechanism. You have to move your arms and hands to feed yourself, just like a fish has to move its body towards the prey or away from the substrate to help yank the prey off of the ground. And so that makes feeding a really exciting topic because it's so crucially important to survival, but it also affects every different aspect of the way that the animal uses its body. So my dissertation research supported by ARCS has already shown that the expansive ability of skulls evolves over 13 times faster in fishes that capture their prey only with suction than fishes that augment that mechanism with biting. And in a recent project, my collaborators and I measured the body shape of over 1,500 species of reef fishes from the collections at the Smithsonian Museum. And we compared body shapes by different feeding mechanisms. And so what we found is that augmenting the feeding mechanism with biting allows access to really deep-bodied body shapes that nearly disc-like, that are almost completely off limits from fishes using other ways of feeding. So what we found is that there's a really strong directional selection for fishes using biting to evolve those disc-like body shapes, and they actually are evolving them faster than anybody else. So there's a really direct link between what you eat and how you are shaped. So I'm really grateful to the ARCS Foundation. ARCS has given me crucial support, allowing me to do the really time-intensive research that's crucial to working with large data sets like this one. So thank you, ARCS.